So sensitivity is one of the fundamental properties of a telescope. The other one is resolution. Now, resolution is a concept that you might be familiar with from images on a computer, for example, and it's some measure of how sharp that image is. Another way of measuring resolution, which you might be familiar with, is a normal eye test. An eye test gives you a measure of how sharply you can see details by how small letters you can read. So if your eyesight is extremely poor, if you have a very, very blurry view of the world, then you'll only be able to see very big letters. And then depending on how clearly you can see, you will be able to see things at smaller scales. And then if you have extremely good eyesight, you'll be able to read things on very, very small scales. So when you hear phrases like 20/20 vision, these numbers are actually referring to angular resolution. So the sharpness with which you see with your eyes is the measure that astronomers use to measure how good their telescopes are. How well can you make out the detail in two objects which are very close together, for example. So it was a real revolution when Galileo first used a telescope to make scientific observations of objects in the night sky. Just imagine what it was like to be the first person to be able to see the mountains on the moon, for instance. People for thousands of years had been looking at the moon, and now for the first time people could really see the detail. If you've never done it before, I'd really strongly recommend that you get hold of a pair of binoculars or a telescope and look at the moon and see that incredible detail that having that extra resolution reveals. What applies to an optical telescope applies equally well to a radio telescope or any other type of telescope. In fact, we have different types of telescope depending on the amount of detail we want to look at. Some radio telescopes are well designed to see the broad brush details of an object, whereas other radio telescopes are specifically designed to look at objects in very fine detail, to zoom in and see what's happening on much, much smaller scales.